right? It's going to be 0.5 on one side, 0.5 on the next. Can we calculate the probability up in here? Yes, we can. If we have two of them, we can actually use the range of the big box minus the range of the smaller box. All right, we'll use formulas within Excel to do this, and we can actually calculate the probability between 2 points from a normal bell-shaped curve. When we're dealing with exponential, it's the same concept. Can we find the probabilities up in here? Yes, we can. All right, it's going to say equals to exponential, expon. You see that? All right, dot distribution. All right, and if it's to the left, it is just that expon dot distribution. If it's between two, it's expon dot distribution for your larger one first, then minus your smaller one second, and that will give you the probability in between. If you wanted the probability to the right, every time we're doing probabilities to the right, y'all, we must do 1 minus. All right, whether it's 1 minus expo or 1 minus the normal or 1 minus the normal dot S. So just to go back here really fast so you guys can see this, normal distribution is if we're going from X to probability. If you have your X values, you can find the probability values by using the normal dot distribution formula. If you know your Z value, if you have standardized your value, you can actually use the normal dot S, standard normal numbers, all right, standardized numbers dot distribution, put in that number, and you can find it to the left, to the right, or in between. If it's to the right, we always must do 1 minus. So for my students, I tell them for the normal distribution, you should be thinking in your head of this little dance. X to Z to probability. And I could see myself work. Anyways, I'm not going to bore you with my corny dance. But we're going from X to Z to probability. Let's jump into this assignment, please. All right, so go into Cengage. You can download that for chapter 6. All right, find chapter 6, download it. Also go into Cengage, and let's get this rocking. All right, so go into Cengage, and let's keep this pushing. X to Z to probability. And then we can reverse it by doing the inverse, all right? Probability to Z to X, all right? By using the inverse functions within Excel. All right, so we are now in topic 3, go to task, and we are in 6, assignment 6, chapter 6 assignment. All right, let's get this rolling. Like normal, I will do a dual screen. All right, and we're gonna start off with 06.02, please, 06.02. So I'm just gonna make all of these just a tad bit smaller. I'm gonna take my Cengage and make that a little bigger. I'm gonna make this just a tad bit smaller. All right, hopefully you guys can see this on your end. All right, so 02.0 or 06.02, let's find that. Bam, all right, at least that wasn't the very last one. All right, so I'm just gonna make this smaller so I can see it in total. All right, so here we're dealing with a uniform probability, all right? It's the range of your small box divided by the range of your bigger box. Hopefully this will make sense. So right here, they say the random variable of X is known to be uniformly distributed between these two. This is your big box right here. So for A, the smallest value is 10. The biggest value is 15. Plug it in for yours. What does yours say? All right. Which of the following graphs is correct? You guys should be able to know how to do this. All right. For your X, it should be at 10, and the box should end at 15. All right. Hopefully you see it that you should be able to answer this question. I'm not going to mess with A. All right. Answer it correctly, 10 to 15. Now watch how this works, y'all. Compute P if your X is less than 12.5. So what that means is that is my actual X2 value. It doesn't give me my X1 value. It just gives me this value right here. So that will represent my X2. So 12.5 or whatever shows up on your end. All right. And then for B, we're dealing with B right now. Here is the formula. It's the range of your small box from 12.5 to 10. All right. And then the range of your big box divided by the range of your big box, B divided by 10. So double click, grab the formula, copy that, paste that up in there. Now you can actually double click on X2. Double click on the X2 and select X2's number. Double click on A, grab your A's number. Double click on B, grab your B's number. Double click on A, once again, grab your A's number. Get into the habit, tricks and tips of Excel, of clicking as opposed to typing it in. So if you were to change these numbers, it would automatically update this probability right here. Bam. Let's check to make sure we good. Check your work, please. And we are good. All right. So now you can find what is the probability between two numbers. The betweens are my favorite. All right. How do you find the probability between 12 and 13 of this calculation right here? So my X1 will be 12. All right. My X2 is 13. Cool, cool. Now, what is the probability right here? Grab this formula, copy that, paste that. What is my X2? The range of the larger number minus the smaller number. You guys remember that formula? All right, and then the range of your bigger box. Larger minus smaller. Give me my number, man. All right, and then down here it says, what is your mean? What is your expected value? All right, EX. So here is the formula for expected value. All right, double click on A, grab your A's number. Double click on B, grab your B's number, and that's it. That's how you find the mean if you're dealing with uniform distribution. How do you find the variance? Here's your formula. Copy that, paste that. Double click on B, grab your B. Double click on A, grab your A, and that's it. You square that, divided by 12. These numbers are constant, so leave them alone. Press enter. Let's test it to see if I am right. Come on, Cengage. Scroll down, bam. Let's get that A. All right, good work, good work. Let's move on to the second one, please. Let's go to 6.08. All right. All right, so here you are hiding. All right, so on this one, they're actually giving you the empirical rule. When we standardize numbers, we can actually determine or predetermine what percentage of our data will show up. So if it's 1, -1, or +1 standard deviations away from the mean, we know, or in our mind, we should know that we're dealing with 68% of the data. If it's 2 minus or +2 standard deviations away from the mean, we're dealing with 95% of our data. And then if it's -3 +3 standard deviations away from the mean, then it is 97.7% of our data that we're going to be looking at. So with all of that said, you got, and this is 6.08. All right, I'm going to make mine a little smaller. All right, you can plug in, what is your mean? 150. Cool. What is your standard deviation? All right, 10. All right. Which graph is correct? Which graph is correct if you have your mean and you have your standard deviation? Is it downwards? Is it upwards? Is it downwards like that? Or is it upwards like that? All right, it's simply just selecting which one is correct. All right, so figure that one out. you should be able to select that and get the concept of how it actually looks based on the mean and based on a standard deviation, the spreadness of your data. All right, so I'm gonna let you figure that one out. Let's go to 6.11, please. Actually, I'm just gonna select, this is not correct. I'm just gonna select one randomly, all right? So I can check it off so I don't click on it again. All right, so we're gonna go to 6.11. I thought I saw it somewhere up here. Yes, bam. All right, this is a good one. So let me make this smaller so I can see it all. And let's get to work. All right, so now here it's saying, what is the probability from your Z value? So instead of X to Z to probability, we're going from Z to probability, all right? And when we go from Z to probability, we use the normal.s.distribution function within Excel. So watch how this works. This Z1 is whatever Z value shows up right here. So I will put in -1. All right, so let me do all of these and then I'll do the calculations. What is my Z1 in this example right here? -1 as well, but it's greater than, but I'm just gonna put in -1, cool. What is my Z1 for this one? -1.5. What is my Z1 for this one? -2.5. And then the last one is between, yes, my favorite. Come on, give it to me. Watch how this works. The first number is your Z1, -3, cool. The second number is 0, because some of you guys are gonna see 0, you're gonna get nervous and don't know what to do. Plug it in, man, that's your Z2 value. All right, so now that we have what is Z1, Z2, all right, if this had said X, that would be X1, X, okay, all right. So not to get you guys confused, let's calculate this. Grab the formula. Remember, if it's going to the left, if it's less than or equals to -1, that you just use the formula and that's it. So I'm gonna paste that in there. Leave the function of the formula alone. The only thing that you're replacing is Z. Double click and click it. Press enter and you should have that answer. Let me test to make sure, trust, but verify, you know what I'm saying? Outstanding, all right? If it goes to the right, do you see how it's greater than? Some of you guys in high school hated less than and greater than, the topic of less than and greater than. If you're still confused by it, don't just give up and say, yo, man, I'm not doing this anymore. Be like, put a note in there to yourself, double click on here, all right? Make a note. If you press Alt and Enter or Option and Enter if you're a Mac user, I see these as arrows. The arrow is pointing to the left, is less than. If the arrow is left, make it do what it do for you, all right? And it's gonna show up something like that. Make these Excel templates do what it do for you. Make it make sense. If the arrow is pointing to the right, it is greater than. You always must do 1 minus. Grab it, copy it, paste it, all right? So all you're changing is your Z, and you're using this Z value right here. All right, doesn't this make sense? If to the left at -1, it was 15% or 16%, to the right, wouldn't it be 84%? The entire area must be equal to 1. All right, so both percentages must add up to basically 100%. All right, on this one, it's also saying greater than -1. All right, let's see. Grab this formula, copy, paste, double click on your Z, grab your Z value, bam. All right, same thing, same concept down here. All right, grab your formula, copy it. It's greater than -2.5. Double click on your Z. All right, and this is my favorite. You're doing the range from your largest minus your smallest. Your largest Z value first, Z2, minus your smaller Z value, second, Z1. So just copy from the equals to sign, highlight and copy, Control C or Command C, paste it up in there. Double click on your Z2. Always the larger number, click on the number, bam. Double click on your Z1. Grab the Z1's number, bam. Press enter and you should have your answer. So I'm just gonna plug in that last one just to make sure I got this right. And I will check my work, 987, okay. Bam and bam, let's go. Once this makes sense to you, everything else will flow. Ultimately, where we wanna take you guys is not get caught up with the formulas, but get to the point where, yo, can I find the probabilities to the left? Yeah, man, you can. Use the normal.s, especially if you're using Z. All right, if you're going from Z to probability. Can I find my errors to the right? Yes, man, I must do 1 minus. Yes. If I'm finding it in between 2 points, I must do the larger one first, minus the smaller one, like range, in order to find that probability. Let's go, let's go, let's go. All right, let's move on to 6.12, please. All right. Where was that one? It was somewhere. Yep. All right down here. All right, so I'm gonna make this just a tad bit smaller so I can see it all. All right, you guys should be now familiar with how to do this. Once again, this is a Z, this is Z. All right, so what we're gonna do is, what is my Z1? Isn't that 0? Plug it in. What is my Z2? 0.62. I'm just gonna go through all of these. Negative 1.57, right here, 0. This one, it's going to the right. You see the arrow pointing to the right? All right, so for mine will be 0.07. All right, I'm gonna scroll down. This one right here is negative 0.35, 2.07, and negative 0.71. All right, bam, bam, bam. All right, so now that I got all that up in there, all right, now I can do my calculations. I'm just gonna double click in here, grab this, copy it, paste it. It's between 2 points, between 2 points. When you see 0 is less than or equals to, Z less than or equals to a number, it's between 2 points. So what is my Z2? My larger number. Make sure you're plugging in your number. Double click my smaller number. Bam. All right, and you guys could go through the rest of these. I am gonna just do this last one just to make sure that I'm right. Copy that, paste that. All right, make sure you're replacing your Z. Double click, grab the Z value, and press enter. All right, so this guy right here is gonna be basically 23%, but they want 4 decimal places. And my first one was what? This guy was the same thing, 23% basically, 2.4. All right, check my work. Give me that, give me that. Let's get my A. Let's go, let's go, let's go. Good job. Hopefully you guys are getting the concept. If it's between 2, then you can find that probability. If it's to the left, you can find that probability by using the very normal formula. If it's to the right, it's 1 minus. Once you get that, man, you're golden. You got this down packed. All right, so with that said, let's go on. I'm not sure if that one is going to be on the exam, but make sure you get this one right. I believe that one is on the exam. All right, so where we at? We're going to go to 6.17, please. 6.17. Bam. All right. So for me, when I'm reading these word problems, my mind is set up or conditioned to look for the main things that I need. All right. If I know I'm dealing with probabilities and stuff like that, I know I'm going to need the mean. I know I'm going to need the standard deviation. I know I'm going to need my X1 values. So can you practice this with me? Look quickly on here. Do you see the mean? Any number on here is the mean, the average of anything. Oh, look, it says mean. Okay, plug it in for your number, please. What is your standard deviation? You saw quickly, you saw that? 10.5. Now, please read this example to kind of get the business sense of how they're asking these questions. But for this purpose, I just want to show you how to get to the main part of it, the probabilities. All right. Look right here, it says, what is the probability that a Dutch male is shorter than 175 centimeters? All right, so the X1 is 175 centimeters. X represents a real number. Then we convert it to a standard number, and then we find the probability of that number. So we're going from X to the probability. So here's your formula. Grab it, highlight it, copy it, and paste it. All right, what is my X1? Grab it. Double click on mean, grab your means number. What is your standard deviation? Grab the number. And it always ends in true. So let's check our work. Basically 22%. All right, that is correct. Now, if it's greater than, what is my X2 for this one? 195. Plug it in. All right. Watch how they word between. What is the probability that a Dutch male is between 173 and 193? So plug it in. 173 for your X1, 193 for your X2. And you guys can plug in and get your answers right here. X3. All right, out of a random sample of 1,000, all right, Dutchmen, how many would we expect to be taller than 190 centimeters? So your X3 is 190. Your sample size is 1,000, all right? Here is your formula. All you're doing is this formula times 1,000. So copy that, paste this, all right? What is your X3? Double click. Grab your X3's number. What is your mean? Double click, scroll up and grab your mean's number. What is your standard deviation? Double click, grab your standard deviation's number. And then on the back here, make sure you're seeing this back part. It says N. If you double click on N, grab your N's number. All right, and then press enter. And based on mine, it's 252. Check your work, make sure we are good. Bam. All right, outstanding. Good work, keep going, keep going. Let's move on to MC06-023. I'm gonna make that somewhat smaller so I can see it all. And that one is MC. All right, that's my last one. Okay, I gotta find that one. Okay. All right here. This one here is an interesting question, but please, it's simple. Please get it right. All right. A normal probability distribution is a continuous probability distribution. Note that to self. All right, but check your work just to make sure. All right. So on here, if you can't see it all, just go between A and B and drag it over so you can see it all. All right, is a continuous. So this first one, if you're a Mac user, you're just gonna have to change the font color, so you know that that's the correct one. All right, perfect. Let's move on to the next one. 06.25, please. 06.25. All right, bam. All right, on this one, it is saying the median, right? But really and truly, I believe they made a mistake. They should have said the mean. All right, but in this example, what is your median or your mean? All right, in this example, it is 75,847. Cool. All right, and what is the standard deviation? All right, plug in your numbers, please. All right, what is the probability that a household in Maryland has an annual income of $100,000? All right, so $100,000. All right. But watch this, $100,000 or more. When it's or more or greater than or increasing, it is to the right. Every time we're trying to find probabilities to the right, we must do 1 minus. So this is why this is this formula right here. Copy that, paste that, double click on your X. What is your X value? 100,000. Give me that, man. Give me that. The mean, all right, you already got that. Your standard deviation, you already got that, and it always ends in true. All right, basically 24%. Check your work just to make sure. Outstanding. All right, you guys can do this one right here. This one should be 40,000 or less. 40,000 or less. This one here should be between 50,000 and 70,000. What is the probability that based on this data that this household is going to make between these two values? This is very useful in the business world. So get this concept down pat. But this last one is what I really want to focus in on. All right, make sure you guys get your X1 and X2 values for these. All right. So let me just do this one right here, and then you guys should be good. Copy this, paste this. What is my X2 value? It's always your larger number first minus the smaller number. Double click and click the number. All right. So this one would be 21% basically. All right, so now hear this in the reverse. What is the annual income of a household in the 90th percentile of annual household incomes in Maryland to the nearest dollar? All right, so I'm gonna scroll down on this. All right, 90th percent, you gotta change that to a decimal, 0.90. All right. And then we're going to use the inverted formula. We're going from 90th down. So here's the inverted formula. Copy it, paste that, and double click on your P and grab your P's number. It's just as simple. Press enter and to the nearest whole number. All right. So when we're dealing with whole numbers, just make sure you're doing it right and it's showing you an actual whole number. This is not sample size, so you don't have to worry like before how we have to round up. Just put in your whole number, check your work. They're going to basically be making $119,163. Bam. All right, doing good so far. This one is on your exam, so please be aware of it. This one is on your exam. All right, so let's go to 6.27. Let's make sure that we have this one correct. All right. So in this example, they have 1/3 e minus x over 3. All right. So what I'm going to do is I'm going to maximize this, and I'm going to make sure that I got e minus x over, and then the number 3. All right, so this is correct. If I make this bigger, all right, the number 3. The number 3 is actually my mu. So if you guys were to go to the very first slide, all right, or the one that says formula key, all right, this guy right here is the actual formula for the probability of x less than or equal to x0. And this is the actual formula right here. So I'm going to zoom in. I'm going to slide this over. All right. So all of this is what I really need for this problem right here. So let me do this. So watch here, the mu, x minus x0 divided by mu. All right. This mu is your mean. How do you calculate lambda? Lambda is 1 divided by the mean. All right. So I just want to kind of give you guys a quick understanding of this. All right. This is this problem that we're going to be using right here. All right, so let's go back to our problem. Sorry for bouncing around, but I just want to emphasize this. All right, and if I go back into Cengage, it says consider the following exponential probability density function. This one is dealing with exponential probability. Make sure that you're making these Excel templates do what they do for you. Make sure it is correct. All right. So on this one right here, all right, which formula is correct? Mine says 3. Yours might say 4 or 5 or 10. Right here, when you're dealing with the exponent, all right, minus x over what? All right, make sure mine is 3. All right. So where is the formula for this? This is the formula right here. All right, so which one is correct? Let me go back to Cengage. Choose the correct one. Choose the correct one out of these right here. All right, hopefully you can see which one is correct and answer that. All right, now here is where we're gonna have some interesting things to work out on our own. All right, we see x is less than or equal to 1. So my x1 in this example is 1. All right, I'm going to go back, get Cengage up in here. For this one, it is 3. All right, for part C, my x2, we're going to call that x2. That is 3. All right, this one is 5. My x3 is 5. All right. This one here is between my favorites, 1 and 5. Make sure you get this one right on your exam. All right, watch this now. It says, what is the probability of x that is less than x1? Do we really use the normal distribution formula for exponentials? Look at this, look at this, look at this. We actually use the exponential, right, dot distribution formula. So we got to make sure our Excel is right, correct it, make sure that these Excels are doing what they do for you. All right, so we're going to be using this. All right, this first value is our X value. This second value is our lambda value, and then it ends in true. So watch me on this. Let me find that one again. I'm going to click on that. All right. So there's 2 parts that are missing. So follow me on this, please. If you click on the number 4, right click on the number 4 and click on insert, here's a trick and a tip within Excel. It adds an entire row. And watch, all of the layout that I had for this one above shows up right here. So this one, I'm going to call my mu. You can put average or mu, and then parentheses, the little u. All right. So this value right here, this 3 right here, is my average, is my mu. So I'm going to put in 3 in my example. Put in your example, please. All right. Now, I also need to add one more. So I'm going to go to the number 5, right click, and insert another row. Tricks and tips of Excel. This one, I need to figure out my lambda. All right. So lambda, lambda. All right. Now, what is the formula for lambda? It is 1 over your mean, 1 divided by your mean. So I'm going to go within this row. Below this row, I'm going to add my formula to this actual row. Remember, if you press Alt and Enter, if you're a Windows user, or if you press Options and Enter, if you're a Mac user, you'll be able to go down within that row. So I'm going to put equals to 1 divided by U. U represents my mean or my average. All right, and I'll press Enter. Do you see how we're creating these formulas within Excel? We've got to make these templates do what it do for you. You got this. All right, so how do I calculate my lambda? It simply equals to 1, you can actually type in 1 because that will never change, 1 divided by, and click on your U. Click it. Bam. All right, so this is my lambda. So now I got to change this formula because this is not right. So just to not so I don't waste time, I'm just going to highlight norm and change it to X pawn. X pawn. All right, I know it's going to use my X1. I know it's going to use my lambda. I'm going to highlight mean and standard deviation and leave the comma alone. LAMDA, and it ends in true. All right. So now that I have this, and now that you guys have this set up, you should be able to answer that first question. What is the probability, this is for exponential distributions, all right, of less than 1? So watch this, grab the formula, copy that, paste that, double click. What is your X1's number? Double click on X1 and grab the number. Double click on your lambda, grab your lambda right down here. And it ends in true. And bam, you should have that answer. So let me make that just a tad bit smaller. And we're talking about 0.3333, 4 decimal places. Check my work. And uh-oh, I am incorrect. So let me make sure this is 3. All right, where did I go wrong? It's less than X pawn, distribution. Let me make sure I got my formula in there right. I got my X is 1. All right. I got my lambda, which is 1 divided by 3. And it ends in true. All right. So I'm wondering, hang tight. Okay. I put in my lambda value as opposed to my probability value. Hey, make sure you plug it in the right number. This is on your exam. Some of you guys are going to do this exact same thing. Don't do it. Get the right, put the right answer in there, 0.2835. All right. Then check your work. On the homework assignment, you guys get a chance to check this out and make sure it is correct. On the exam, you got to be precise. So if you need to make a note, this one, just so that way you know which one to plug in, don't mess it up. Don't mess it up. All right. Now, for each one of these, we're going to have to change all of them. So I'm going to maximize this. I'm going to make this bigger so you guys can actually see it. All right, I'm just going to make it like that. All right. And we need to do the same thing. We need to add averages and lambda for each one of these and make them right. So follow me on this, please. If you right click on the number 9 and insert two new rows. One, if you press, here's a trick and a tip within Excel. If you press F4, it should add or redo what you just did in the past within Excel. Tricks and tips. All right. I'm going to scroll down. I'm going to go to 14, right click. Actually, you could just click on 14 and press F4. It should add it and add it. All right. You can also go down to 20, click it, click on the number 20 and press F4 and F4. One for the average, one for the mean. All right, so I'm gonna go up here. I'm gonna highlight the average, and I'm gonna go over to the number, go down to lambda and the number, all 4 of these cells, copy it, Control C, and I'm gonna paste it down here, Control V. All right, I'm gonna scroll down, click it on this one, Control V. I'm gonna go down, click it on this one, Control V or Command V, bam. All right, on these, my X values are gonna change. All right, it's not gonna be the same as this. So for this second one, I'm just gonna delete my X2. Actually, I did do it right. Never mind, I already updated these numbers, so it should be right. Let me make sure. Perfect. So that one is that. That one is 1 divided by 3. All right. And this one should be right. Perfect. All right. So I have everything that I need, but my formula is still messed up, y'all. So if I were you, this is what I would do. Make it do what it do for you. Make this make sense. Copy your formula, just not the equals to sign, from the E, right before the E, all the way to the end, all the way to the parentheses. Copy that. And what I will do is double click on this formula down here for C. And from the normal, from the end, before the end, highlight it all and paste it, Control V. All right, this is gonna be X2. Delete X2. So that way I don't mess myself up. I'm gonna scroll down, I'm gonna go this guy right here. I'm gonna replace this normal distribution with a formula, paste it in there. And this is gonna be X3. All right, and then one more. Yes, my in-between. So this one you're gonna have to take your time on. So double click, grab from normal all the way to the true, not including the minus, right before the minus sign. Paste your formula. Remember, it's the larger number, so you gotta do X2 on this one, X2. All right, and then go from the normal for the second part of your formula, paste it in there. And remember, this is X1, so you can leave that alone. All right, so those are your formulas. Keep this rolling. Let's see if we can get these answers. I'm gonna do all of these, copy that, paste this, double click on X2, grab my X2's number, double click on lambda, grab my lambda's number, and enter. Cool. And what I'm gonna do is, let me just check to make sure I did this right. So for part C, it will be 0.3679. Check my work. Bam. All right. I'm going to do this one as well. Let's make sure that these are right. Copy, paste. X3 is 5. Yep. Lambda is that. Enter. Cool, cool. And then this last one, my in-between, I'm going to copy this formula. I'm going to paste it up in here. X2 is 5. X1 is 1. And bam. Uh-oh. Oh, I forgot to do my lambdas. Lambda, bam, lambda, bam, true, bam. All right, let's plug in these numbers. Let's make sure I'm leading you guys in the right way. 25277, check your work. Let's go, let's go, let's go, let's go. So for these Excels, make sure that you have the right formulas in there. You gotta make it do what it do for you. All right, so if I went too fast, stop the video, go back and see how I'm adding cells, how I'm adding the formulas and all of that stuff, and get it right. This will show up on your exam. So get it right, get it right, get it right, get it right. All right, I think we have like 2 more. So that one was that one. Let's go, if you would, please. Let me make sure. Yes. Let's go to 6.37, please. 6.37. I'm going to make that smaller so I can see this. Bam. All right, so quickly what I'm looking for is the mean, and I quickly see it. What I'm looking for is the standard deviation. Plug in those numbers, 2,800, standard deviation of 860. That's the spreadness. All right, what is the probability that there's 2,000 or fewer? So it's less, 2,000. All right, here's your formula, grab it, highlight it, copy it, paste it up in there. My X1 is 2,000. All right, and that will be that mean. I got my standard deviation, it's true. Well, let me plug this in. All right, so you guys should be very familiar with this pattern right now. All right, you got that. What is it between those two? Plug it in between that two, and I'm just gonna do this last one. All right, so right here, assuming that it is 0.01. All right, so 0.01. All right, and it exceeds. All right, so when it says exceeds, we must do 1 minus. So in order to find our p-value, it's equal to 1 minus the p exceeded. So in essence, it's equal to 1 minus, click it. All right, p exceeds or to the right, yes? So once we got that, bam, it's 99 or 0.99, all right? So we can do the inverted formula, copy this, paste this, double click on P, grab my P's number, all right, and then press enter, and we're looking at 4801. Let's check our work. Bam. Let's go, let's go, let's go. Let's get that A. All right, so for this last one, all right, I'm just gonna maximize this so I can see it all and make it smaller. All right, and then I'm gonna click on this guy right here. All right, you guys should be able to figure out this one. Excel, normal.inverted function can be used to compute what? Normal inverted. So basically, when you see the inverted, you're basically going from your probability to your X value. All right, cumulative probability for a normal distribution X value. All right, the normal distribution X value given a cumulative probability. All right, cumulative probability for standard normal value and the standard. All right, you guys should be able to figure this one out. All right, but in essence, it is not the Z ones. So even if you were to guess one of these, you should know that it's going from your probability to your X value. All right, these two are pretty close. All right, just figure out which one it is, and you should be able to get your answer and rock and roll. All right, I'm gonna let you guys figure that one out. So that is basically my class. What I wanted you guys to get is that when we're dealing with continuous normal probabilities, we can find the probabilities under the curve. The entire probability is equal to 1. For uniform, it is a small box, the range of the small box divided by the range of the bigger box. When we're dealing with normal distribution, if it's going to the left and you're going from X to probability, you use the normal distribution function. If you're going from Z to probability, you use the normal.S standard distribution formula or function to get your answer. If it's going to the right, we must do 1 minus. If it's between two, it is the bigger value minus the smaller value. And you're using the function and you will get your answer. If you want to invert it, if you're going from your probability back to your X, it is the inverted and so on. Anyways, not going to bore you with that, but hopefully you got the concept. Hopefully you see how to make it work. Hopefully you've made this Excel do what it do for you. Let's get that A. Have a great day. Thank you.